And this is our third and final session on speeding up images. Giuseppe Scrivano is going to give us a short presentation on his work in terms of speeding up images pulls, which is complementary to Kohei's work if you watch the last session. And then after that, we are going to open it for discussion around making container images faster. As with the other discussion sessions, you can participate either via chat by asking your questions or making your comments in chat, or you can request to appear on video, which you do by finding the request to share audio and video link on your screen, and then join the discussion out loud. But in the meantime, Giuseppe, want to get started?
Yeah, sure. So, Kohei already gave a good JSTD chunk. When I started working on it, I was trying to solve a different problem than lazy pooling, and it's how we can improve traditional image pools, so without requiring a fuse file system. The reason why I started to work on JSTD, it's basically for two reasons. The first one is that I want to push the new compression format, JSTD, that it's much faster than gzip, that the OCI world got stuck since the beginning. So I took this chance to work on something that's just faster. And also, I wanted to solve some of the problems I saw in the initial StarGZip format. And the StarGZip format actually needs a file that is added to the tarball itself for the metadata. Instead, with JSTD, the metadata can be moved to the compression layer so that the original payload is unchanged, but any additional metadata is added as part of the compression. What it means is that for OCI images, the diff ID will be unchanged because once uncompressed, it's exactly the same as before being compressed. And clients that don't understand the new metadata will just ignore it. And that's defined in the JSTD compression format. So there is no way to confuse clients that are not aware of the additional metadata. Yeah, looks similar to the slide Kohei introduced. Yeah, so basically every file is compressed on its own, and it's possible to retrieve it individually. So when we pull an image, what we currently do today is to pull the entire tarball. Instead, with these new formats, JSTD or StarGZip, we can fetch only the missing files. So there are two things that I want to improve. First of all is the network deduplication. Like there is no need to pull files that are already present local. That it's if you already pulled an image that has similar files, and you are going to pull a second image that shares some of the files with the first image, you can just skip what was already pulled the first time and download only the different ones. Also, another thing that I want to take advantage is the local storage. So taking advantage that we know that the checksum for the digest for each file in the image. I also want to take advantage of the ref-link feature in a modern file system like ButterFS and XFS. That it's similar to hard links, but like if you're familiar with hard links, like they share the high node. So any change in the metadata will be propagated to any other hard link. Instead, the refs work just by sharing the data allocations. files that have a different metadata can still share the storage. And if any of them is changed, the file system takes care of the copy and writing and create a new file. So without modifying the original one. So there are several points I looked at in the proof of concept. And so I will look at the duplication of files without their images, the duplication of files with a host. Imagine you're running a Fedora host and then you pull a Fedora image. You will end up fetching files that are already present locally. So why not take advantage of that as well? So this brings some advantages, like there is less usage since the files share the storage. And also it's faster to create them. Like creating a link, it's just creating the high node basically. So it's faster than a copying file. Yeah. So that's all I wanted to introduce with the JSTD chunk, and we can discuss.
Okay, so I just wanted to throw out a few comments as we go forward with this. I think, by the way, all three solutions look really, really cool. I think probably the number one complaint about using containers is around speed, and that's why we've had this huge push to shrink the size of images. And over time, I think shrinking the size of images was exactly the wrong thing to do, because we end up with really very little sharing of images. So if you think about the whole layer stack, and that brings up multiple problems. I believe that the base image should be large, and that if you had a base image that was large, say all your containers would say share the same glibc, then they wouldn't have to be continuously pulling it. The way we currently run containers, we have very small base images with almost nothing in them, and then everybody's pulling in over and over again the same content in different storage layers. That causes problems, obviously, in storage, but it also causes problems in the kernel. The kernel only understands when you load. If I load on a normal system, a non-container system, 2 images, say 2 Apache servers on the system, the kernel is smart enough to know that the Apache server is already loaded into memory, so it only loads into memory once, and both processes are able to use it. The way we run containers is we tend to basically, as I said, pull down 2 different versions of Apache. It's the same version of Apache, 2 different layers. They end up being 2 different inodes, and it confuses the kernel, so they're not shared. So one of the things I'm looking for with this is not only speeding up pulls to the system, but also to help with memory utilization. So if you go to large Kubernetes clusters where we're using hundreds of containers, if 100 containers are all running their own version of Nginx, obviously wasting a ton of memory on the system. So that's what that's one of the problems I think with Fuse systems right now. So could you guys comment on that? How do your solutions address that problem?
Kohei, Giuseppe, Tao?
Yeah, in our case, yeah. Can you hear me?
Yes.
Yeah.
Yeah, sure. In our use case, we internally have tens or maybe in some extreme case, more than 100 gigabytes container images locally, internally, in our production system, actually. And our base image is already very large. We have we usually have 1 to 5 gigabytes base images, but there are actually applications and users who even save their data in their container image. So we are dealing extremely large container images, and that's why we we look into how to data pooling and implementing the data in the first place. Not 100 megabyte, 100 gigabyte. It's a very extreme use case, but normally we see tens of gigabytes container images.
I think now Giuseppe's solution actually fixes that. You handle that, right, Giuseppe?
Yeah, because well, if the file system supports it, it tries to use ref links for sharing files among different images. So,
yeah, and for ref links, that's a no-go for us. We're using ext4, so we don't have ref link capability there.
Okay. If you're ready for it, we have a question from P. Larson. Is there a way to provide the container image endpoint on a network device so multiple nodes can share the same pulled image as long as the signature matches? When using more than a few container hosts pulling the same image, storing the same image on every node just adds a lot of storage and overhead repeated over and over again.
I believe Podman has additional image store for achieving this, I believe.
Yep. So with Podman and Cryo and Builder, we basically use container storage. Container storage has the ability to share additional images, and that additional images could be stored on top of some kind of remote file system. So the idea was to use something like NFS or CIFS or some other tool to basically pull images to one server and then to share that server to multiple nodes and take advantage of NFS. Now, one of the issues with that is you have potential for latency. If the network has problems, that the applications could start to hang. So yeah, there is ability to do that. I actually prefer the idea of using something like that, but so far it has not been adopted widely.
In our use case, we have a special deployment for one of our products, and then for that we support different storage backends, and in this environment we deploy an NFS file system for different nodes. So we put the metadata and data on the same NFS file system. So and we don't use any local cache for each node. Every node is accessing the same NFS file system for their container data. So I think it's a similar situation proposed by Larson.
And Containerd also has remote snapshot functionality. I don't know is there any implementation that supports NFS, but I believe remote snapshot by implementing remote snapshot for leveraging NFS, I think Containerd also can do this kind of thing.
Okay, another question. Giuseppe was talking about using files from the operating system instead of downloading the image bits from the registry. Isn't sharing files from the operating system a possible security problem?
Yes, it could be. That's why it's limited to file system where ref links are supported, so that if a container somehow managed to escape and rewrite that file, that won't affect the file on the host. And also the duplication should be limited to some specific paths like /use, and so we're expected to have just binary files, and not touch stuff under home or etc. So that a registry could detect whether a file is present on the node.
Wouldn't you? You would have to have the checksum as well, right? So you'd have to know the checksum of the file that you want to be able to read.
Yeah. So the checksums.
I think locking it into /user would probably solve that problem. I don't think many people have data that they don't want shared out of /user, and it would be up to the administrator installing machine to set it up if they wanted to use this feature.
Yeah.
Okay. We have some additional questions, so just let me know when you're done.
Yep, go.
Okay. Any thoughts on having multiple Podman instances share a single image cache? Nizar asks because they have use cases where they run Podman inside containers, therefore having multiple Podman instances on the same host, and they would like them to share the same cache.
Well, you can do that with additional stores right now. You just have to. So if you're running Podman inside the containers, you'd have to volume mount in the additional images into them. Giuseppe and I have played a little bit with additional stores and allowing you to have, say, a root store that you shared into the containers. The problem is if you're doing this with root full containers, it's not a problem. With rootless containers, you have to worry about making sure that all files in the underlying shared storage is world readable in order for it to work. And then we've been able to get that to work. So you could have, a large store of images owned by root, but they all the files in it would have to be world accessible. Is that correct, Giuseppe?
Yeah, if you the discussion we had at the kernel features, like we are looking at with Fuse over FS, this problem is solved by storing the real file ownership in an extended attribute, so that the image cache can be made word readable. So every user on the host can get access to that. And then a Fuse file system will rewrite the permissions that the container sees to what's stored in the extended attribute. So the Fuse file system, even if it's running with low privileges, like it's running in a user namespace, is able to read the image store because it's word readable, and but it won't have the rights to write there.
Interesting thing is going to right now. If you did this type of sharing, you end up with all the files being owned by basically the unknown user. But now that we have a shifting file system that's been merged in the kernel, we'll be experimenting with basically having rootless containers, shifting those file systems over, or having the ability to shift an additional store over to match the UIDs of the container. Go ahead.
Yeah, that will still be a problem with files in the image that are not readable or accessible, because even if you shift the UID and GID, another user won't be able to get to read that. So
right. They still have to be readable by the underlying storage.
Okay, so take a little out of order. Tao had something to ask Kohei, and then we'll get to Murugapan's question.
Yeah, Kohei. And after learning about your ZSTD checked format, I think the idea is very similar to NetAS format, where you have a Z4 checked format and with a Merkle tree in the metadata layer. So I'm wondering, what is your metadata layer, and if it is possible for the two projects to cooperate somehow on the FASN format?
Yes. First of all, we don't use LZ4 format currently. We are yes, and Yeah, we're currently using our metadata format is called TOC, and we are using dedicated metadata format for storing all file metadata, and it is just a JSON file that contains all files metadata, actually it works, but I don't think it optimal. So I think we can cooperate on image file system format somehow. But I currently I don't have any idea. How about the STD chunked, Giuseppe?
Well, for JSP chunk, now I'm trying to use the same metadata that you are using for Easter, so that it will be more. For the metadata, I think that's fine. We can share the same the same format. Because what I care with JSTD is that the metadata can be added in the compression layer. So clients that don't care about it will just ignore. And that diff ID will be unchanged. That's also something
Okay, so you still have TOC for every layer, right?
Yeah.
Yeah, TOC for every layer. Yeah.
Yeah, but if a canary image have many layers, you will end up with many TOCs and have to either combine them in memory or either have a fuse mount point for each of the layer. That's the reason we choose to have a single metadata layer for a single image in Atlas. But I'm not sure if I misunderstand anything.
Yeah, well, if you have a metadata just for the image, like you will store just the final view of the image, then you lose the ability of the layering, the duplication, because you will need to store the image. I don't know how you store it locally, but when I was considering this possibility, you will end up storing the image fully in the local storage. Instead, with keeping each layer separate, there is still the layer deduplication that exists today. So we don't lose also.
I understand that. And with Atlas, we use the chunked level deduplication. So even if we lose the layer deduplication, we can still share different chunks for different image and different layers.
Yeah, that's also something that I would like to address. Just the issue is that if using rolling checksum, or that would help with the network bandwidth, but it won't help locally with ref links, because ref links are limited to the block size. So
that's a different angle. If you look at it from the file system view, and you will want to use ref link to link different chunks, but if you look at it from a Eurospace file system point of view, you can point to the same chunk with different metadata. So you don't have to rely on the ref link capability of the local file system. I'm not sure. I'm not saying the data method is better, but I just want to propose to see how we can cooperate on the file system image format right now.
Yeah, I don't think that the chunk size would affect the format. It's just a tuning configuration. Like if you want to optimize for the or for the local storage, like taking into account the ref links work, and that they require the duplication with the block size.
Yeah. I think we can take this offline, and first we can have a baseline, so we can try to discuss and see how we can cooperate on this, and of course this won't be solved in this meeting, so we can I email you guys later after the meeting, and we can see where we can start.
Awesome.
Okay.
Since you've been very patient, I want to actually throw in Murugapan's question, which is there any plan? Is anybody working on optimization from the container registry side, such as, for example, using bidirectional gRPC streams for pulling image layers instead of multiple HTTP requests? Does anybody know anybody's working on that kind of optimization?
Not that I know. For this chunk, one thing I wanted to address, and also Serge is addressing, is that it doesn't affect how the image is stored in the registry. So we don't need to change anything on the registry side.
I would say the number one goal with all three of these projects, somewhat following it, is that there's a huge installed base of container engines out there. There's a huge installed base of container registries. Anything that breaks the vast majority of those is not going to, to me, it's not going to fly. It's not going to, it's not going to happen probably in my lifetime. I mean, there's just too much, so redesigning the tarballs to be a different format, I think those are all, sure, we can move that way, but it's going to take years and years to ever get to the point where you have a majority of users using it. So I think keeping this as simple as possible on the container registry side, so that we don't break 90% of the container registries, is the best way forward. One of the problems with Giuseppe's format right now is that older versions of Docker don't support it, so that there's, and so we have to get Docker to eventually update to be able to handle ZSTD. But the rest of them all look like they handle it on any registry, which is what really is the goal.
Okay. One more comment here that we have in the session. Scrivano says, all the improvements I see to improve container images in general are coupling storage and transport. He thinks most storage issues should be resolved in the file system, like with ref links, even hiding lazy pulling without bothering the container engine with these concerns. Is the difficulty to get these concerns addressed in the file systems the reason for approaching them in the imaging format? Is it support for other operating systems than Linux the reason? In other words, he's asking, why not make this a file system problem?
Some of the issues could be moved at the file system level, but that will require like an additional work. Like, look, I mean, you can already today duplicate files in the containers image. Like you look for duplicates and create ref links. But then it has a cost when you create that file, because you would create it fully and then the duplicate. Instead, if you already take care in the image format of such problem, you can skip completely creating the file. You would create directly the ref link. At least this is how I was looking at it from the JSTD chunked formats.
Okay, and unfortunately,